Great. So fun format for you maybe, not so much for me at least. But I have one pro tip: if you ever are so dumb to do this, then do the first 2 slides about the title and yourself, so you can talk about other stuff while mentally preparing for the next 4.5 minutes. I know most of you can read, so I'm not going to talk about myself. The topic I'm discussing today is resilience engineering. I'm going to tell you in 5 minutes what resilience is, what foundations resilience engineering is built on, and then talk about something called the socio-technical system. And at the end, we all know how to practice resilience engineering. It's not that hard. You can learn it in 5 minutes. Okay, so in our language, what we try to do when creating systems that can handle a little peak load and will survive in the future is do this stuff: create redundant systems, make sure that they can fall back, that there are failover strategies that you of course tested daily, that there are retry mechanisms in your code. So at the application and system level, you are ready for an attack or a little peak load or a surprise. But the main problem with this type of thinking is that you're trying to make a very robust system. And what you're thinking about is mostly classical risk. And if we plot risk on 2 axes, where awareness and knowledge go from a little to a lot, then we see that there are 3 types of risks where robustness helps us. But to get a resilient system, you will have to mitigate something that we don't know, the unknown unknowns. So classical risks, those are easy, secrets, things you can extrapolate. Those you will mitigate against with robust systems, but with resilient systems, you can handle the unknown unknowns. If you would be a castle designer, for example, you could mitigate against all these risks, but in the future, your castle might be attacked by a virus-transmitting nanobot dropped from a drone, and then your castle is useless. So what does a resilient system look like? Bone is a good example. Every time you put pressure on your bones by running or walking or falling from your bike while your wife is in the hospital pregnant with your 2nd daughter, like I did, your bones get a little more robust or more resilient. And that's what you want on a system level. Every time you put pressure on the system, it should improve itself. Robust systems will break down over time. Resilient systems will improve themselves over time. So what do you need to do then? Do you need to minimize variance, write documentation, enforce stuff? Yes, but that's still robustness thinking. To get a resilient system, you need to do more. You need to shift focusing on the things that can go wrong and try to fix them in advance, and shift your thinking to making sure your system does better over time, create more success every day. And for that, you need to stop thinking about systems in terms of just technology. A bunch of features crammed together is not a system. There's also the operators like you and I, the developers, the users, and together they form the socio-technical system. So the technology and the human together, that's the system. That's systems thinking. And the thing you have in your head when thinking about a system is just a model. And all models are, yes, tough crowd, are wrong, exactly. So if I try to imagine a very simple system, like this one, like this one, like this one, then I'd imagine that if I press B, the light would go on. But what if it doesn't? I need to open the box, and then I need to reimagine the system as I was having it in my head. And if you are working at Netflix or Amazon or Twitter or Spotify or whatever these days, the system is much more complex than you are imagining. And it's impossible to get a complete picture. So that's not helping in preventing risk, and it's certainly not helping in improving success. So what you need to realize is that you need to practice the system. So the humans and technology need to be put under stress in game days or with chaos engineering or fire drills, and you need to learn what happens, not just with the technology. Don't just stare at the monitoring. See what people do, how they communicate, what processes they use, how people are talking with each other, and fix all of those. And if an accident happens, that should be regarded as a gift, because then you've discovered a boundary of your system. You need to look again at what happened and how people are reacting, share that information so the next time your system won't do the same thing again in the exact same situation, and be better over time. So, resilience is not just robustness, it's something besides robustness. It's about creating success, not preventing error, and it's about technology and the people interacting with it. Thank you. I'll share a link to this on Twitter after this, and have fun today. Bye-bye.